Live streaming. Yes, I think we are now live. So, hi everyone. Welcome to our webinar, Building Robust Track Systems. So, today we have Pavan, who is, I think, doing the webinar with us for the first time, right? Is that right, Pavan? You seem to be on mute.
No, no, I have done like two webinars before.
Okay,
This
okay,
is my
okay,
third
amazing.
webinar.
So, yeah, it's after very long that you are
Yeah,
doing.
after very long. Yeah, yeah, after
And
very
it's
long.
been really long. So we have Pavan. He's a developer advocate here at Single Store, and he's amazing at his work. So if you have any doubts related to this topic, please feel free to add it in using the Q&A button. Please note that you are currently in a Zoom listen only mode, and any interaction that you can do with the host or the speakers will be done via the Zoom Q&A button. My name is Yukti. I am a growth engineer here at Single Store, and one of my main jobs is to host and coordinate the webinars that we bring to the tech community. And we have an amazing panel of experts, and today we have Pavan that's going to deliver this webinar. Towards the end of the session, we will also have a demo, so stay tuned for that. And yeah, I think I will be providing the resources like future events, everything in the chat that, or if there's anything else that you might need for the session. Pavan, there's no notebook for this webinar, right?
It is there. I'll share. I mean, like you can
Yeah,
share
amazing.
after.
You can put it on Slack, and I will
Yeah,
add
in
everything that's related to this webinar in the chat. So keep an eye out. And if there's anything that you like, if you have any questions, any concerns, any feedback, feel free to reach out to me on LinkedIn, or you can use the Q&A button for that. And yes, Abel, I see the question. The source code will be available. I will be putting everything in the chat and the link to try for free. Just note that Single Store offers $600 worth of credits for free. So if you want to start and follow along in real time, which is something that we highly encourage, because a lot of users tend to benefit from it because Pavan is live. And if you have any questions, you can directly interact with us and we can get it sorted so that you have everything in place correctly. So, yeah, I think I'll hand the mic over to Pavan now, and yeah, keep an eye out for the resources. Okay, thank you, everyone.
thanks, Yukti. So we are recording this now. We are live now. I mean,
Yes,
and we have almost
we got
134
recorded
people.
and we are live.
Sure. Okay. Hey guys, thanks for joining. My name is Pawan, and I'm a developer advocate at Single Store. So welcome to this today's webinar on building robust RAG systems using um both of these frameworks like LangChain and LlamaIndex. Hope I'm audible and my screen is visible, the PPT
Yes,
presentation,
everything is fine.
right? Okay, cool. So yeah, let's get started. This is my table of contents. I'm going to talk about building AI applications, how complex this journey is, and I'll talk about LLMs, large language models. I'll talk about chatbot, then I'll touch upon the framework that is LangChain and LangChain components, the modules, what we call, and I'll talk about LlamaIndex, the other LLM framework that I'm going to talk today, other than LangChain. And I will talk about retrieval augmented generation in brief. And I'll show you how you can actually build simple RAG applications or systems using LangChain and RAG with LlamaIndex. So I have two demos or tutorials at the end. So let's get started. So building AI applications, right? As you can see the emoji, it's a very complex and multifaceted process that involves a lot of steps, starting from data collection, data pre-processing, feature engineering. So all these things add up a lot of complexity, right? And we also see that there is a skills gap in the industry because AI, the topics, the LLMs that are coming, often, we before it was just traditional LLMs, now multimodal LLMs. So it's the AI industry is moving at a fast pace, and there's a lot to learn, and that's why there's a lot of skills gap still. And Additionally, while building AI applications, ensuring the model's performance through hyperparameter tuning, when it comes to deployment, evaluation, and all these layers add up a lot of challenges to AI engineers, right? And they demand continuous effort and expertise. So we know that there is a skills gap, like I said. So the whole point of adding this slide in the presentation is to make sure to understand that how complex it is to build AI applications, right? So you might say, hey, LLMs are just enough to build AI applications, but it's not actually. LLMs are just one piece of the puzzle while building a robust AI or LLM application. Um, because what LLMs are made up of? They are made up of data, structured, unstructured data from the outside world. It can be videos, YouTube videos, Wikipedia, anything outside. And then comes the architecture. The transformer model is what we call, and then some sort of training. That's how LLMs are made up of, right? So, but LLMs have these type of problems. They have their own knowledge cutoff date because they have these LLMs are trained to certain extent to with a limited data to certain point, and then they usually hallucinate. They made up answers. Sometimes they produce fake answers, and they don't have access to the proprietary data, custom data, right? When you want to build custom AI application, and there is context limitations, limited context window size when it comes to LLMs. So these are some of the problems, right? And like I said, LLMs are just one piece of the puzzle while building robust AI applications. Who will take care of the data management aspect, infrastructure aspect, integration layer, and then application logic? So you need all these things, as you can see in the image, right? You need all these five things to build robust AI applications. So LLMs are not just enough. But you might say there are chatbots using LLMs, right? But while you see this chatbot shown here utilizes LLM model for generating responses and all those things, but it lacks a connected knowledge. There is no custom knowledge connected to it, and it is just a mere very simple chatbot with just produces pre-coded uh, text and outputs the same outputs every time. But effective AI applications require something more than just LLMs, right? We require AI frameworks. That's what we are talking today. So chatbots just using LLMs have these limitations, right? They are restricted to their own training cutoff date, and they can't verify the accuracy of their own responses, right? How would we know that the LLM has generated the answer response? What's the accuracy of that response? And they lack access to real time or custom data. What if you want to build, you are in a healthcare company want to build a custom application? That's where chatbots using LLMs fail, and they can't integrate with business systems or logics. That's where basic LLM chatbot fails. So LLMs aren't just enough. So what exactly do we require? That's where we require LLM frameworks like LangChain and LlamaIndex. So let's see one by one. Let's talk about LangChain first. So it is developed by Harrison Chase, and it came out in October 2022. So LangChain serves as an open source platform to help you build LLM powered applications. So LangChain basically streamlines the intermediate steps that we saw before while building an AI application. So it has all the modules that are required. So that's how LangChain basically works with its modules. We're going to talk about the LangChain modules in the upcoming slides. But let's understand what exactly is the literal meaning of LangChain. You can split the word into two parts. This Lang and chain. Lang comes from the language models. It can be GPT-4, Claude, Llama, Mistral, Palm, and all these LLM models. And chain refers to the concept of how basically LangChain works. It works with a chaining everything. All these components can be chained together to build kind of AI workflows. We'll see in the upcoming slides how we do that. So this is the literal meaning of LangChain, and these are the components how LangChain usually works. LangChain has LLMs, right? You can it's LLM agnostic. You can use open source, closed source LLMs, and it has indexes, it has document loaders, text splitters, good integration with vector stores and retrievers, and you can build agentic systems, leverage LLMs for reasoning to automate decision making, and it has memory component that you can build, right? You can have a chat history, you can have long-term, short-term memory, and other component is chains. You can combine LLMs with modules and prompts to execute sequence of functions. And then there are prompt templates. You can basically build AI applications, just like you can have a custom prompt saying, "Hey, explain me everything as if I'm a 5 year old." So from then on, if you use this type of prompt, your AI application starts to uh, guide the system, and the responses will be like as if you are a 5 year old. So you can use pre-defined templates or prompt templates, or you can have your own custom prompt templates. So these are the basic LangChain components. So using all these things, LangChain basically helps you build AI or RAG applications. So, of course, LangChain has the first mover advantage when it comes to AI frameworks or LLM frameworks. So I just went ahead to see how people are talking about LangChain. So I went to Google Trends and I searched for this keyword LangChain. So as you can see, it is growing up and above. And since it has that first mover advantage, everybody wants to learn LangChain to build their LLM powered applications. And even I saw on Udemy, LangChain is one of the top topics that is discussed recently in their one of the reports. And why exactly companies or people want to learn LangChain? Because of these two principles. One is access custom data, other data such as enterprise data, developer owned data, your own documents. This data awareness is the first principle of LangChain, and the other principle is it helps you to interact with other systems. That's where we call API calling, tool calling. You can have, you can interact with search engines, Python compilers, math calculators, for example. So this agentic principle behavior is the second principle of LangChain. So using all these modules that LangChain has, like LLMs, memory, prompt, agent, you can chain everything. That's how LangChain basically works. You can chain everything and build these type of systems like question answering or docs, summarization, chatbots, querying Tableau data, interacting with APIs, and code understanding. So these are some of the LangChain use cases. So getting started with LangChain is kind of very easy. I'm more of a Python guy, so I usually use pip install LangChain. And if you want to use third-party integrations, you can go for pip install LangChain community. And if you want to use different LLMs according to your use case, you can go for LangChain OpenAI, it can be LangChain Anthropic, if you're using Anthropic LLMs. So yeah, I mean, next, like LLM application development workflow with and without LangChain. As you can see, right, without LangChain, your AI engineers or developers should hard code everything like rate limiting logic, custom AI authentication, custom prompt templates, vector DB integration, which is kind of very complex, and it requires a lot of effort and money. So that's where a framework like LangChain comes with all the modules which has built-in authentication handling, integrated rate limiting, prompt templates, vector store integration, document loaders, memory components, so that your engineers no need to hard code things, but use frameworks like LangChain to just build powerful LLM applications. So that's about LangChain. So now let's talk about LlamaIndex, the other framework, right, to build LLM-powered applications. So LlamaIndex is a data framework, basically, to help you build LLM-powered applications. And LlamaIndex basically, like we saw, right, basic LLM chatbot will have these limitations: no access to current information, cannot verify response accuracy, no connection to external data, limited to training data cutoff, and no business logic integration. So that's where Llama Index comes in to bridge these gaps, and helps you with the LLM engine, knowledge base integration, data connectors, business logic. So all these things. So Let's understand the literal meaning of llama index. Llama means, as you can see, the animal often associated with carrying large loads, symbolizing the ability to store and access large amounts of data. And index refers to the structured way of organizing data for efficient retrieval if you're building RAG or AI applications. So in llama index is basically related to the data organizing and indexing part, as if you want to know exactly. So when we talk about Llama Index, if you go to Llama Index website, there are two parts. One is Llama Cloud, the other one is Llama Index, that is open source. So Llama Cloud basically connects various data sources, Notion, Slack, and all those things to basically helps you ingest and sync data sources easily, build and maintain indexes. So that is where Llama Cloud helps you with build and maintain indexes. And Llama Index basically helps you with as an orchestration layer that processes the indexed data uh, to help you with capabilities like you can build search functionalities, create chatbot applications, and create agentic workflows and all those things. So just understand that there are two parts in when we talk about Llama Index. One is Llama Cloud and Llama Index. So here in this presentation, we are going to talk about we are talking about Llama Index, basically the open source part. So yeah, I mean, just like LangChain we discussed, I also went ahead to Google Trends to see how Llama Index is doing, how people are talking about it over the year. As you can see, people are talking about it like the interest over time is just increasing day by day. I mean, why not? Apart from LangChain sometimes keeps breaking because it's evolving every day. But Llama Index has been little constant with their updates and all those things. And apart from LangChain, the other thing that usually people use is Llama Index to build their LLM powered applications. So this is a simple Llama Index workflow. The We have a document. The document gets loaded and gets parsed, and it gets indexed in a structured format, and all this um, indexed data is stored in a vector store like single store. So when a user query comes in, it goes through the vector store using semantic search, of course, and similarity, and to find the relevant chunks, matching chunks, and that's how the response generation basically happens. So yeah, let's talk about the GenAI dev stack. If you're a GenAI developer and want to build AI applications, you need to be aware of these five layers, that is UI layer, service or chain layer, a model layer, storage layer, infrastructure layer. The whole point of this image or this slide is to show you where exactly the frameworks such as Llama Index and LangChain uh, help you. So in the UI layer, it can be React. Other than React, there are other things. And in the service or chain layer, that's where Llama Index and LangChain come into the picture. And model layer is any open source, closed source models. And storage layer is where your vector databases like single store help you. And infrastructure layer is where the big guys, Azure, AWS, Google Cloud, NVIDIA, uh, help you with the computational resources. Since our demo or tutorial is all about RAG, retrieval augmented generation, so I just wanted to talk a little bit about RAG. So what happens, LLMs usually hallucinate. Now that we have very sophisticated LLMs, but sometimes usually they hallucinate, they come up with their own data, which is fake, sometimes made up answers, sometimes very wrong answers, right? So this process of generating wrong responses is known as LLM hallucination, LLM hallucinating behavior. And there are basically three approaches to mitigate this LLM hallucination. That is, the three approaches are fine tuning, prompt engineering, and the third one is RAG. So RAG is where you basically um, give your LLMs the context about your data. So this data can be augmented using an external database, what we call vector database. So all the context is usually present there in your vector database so that LLM has no chance to hallucinate, but go there to pick the right response, matching response so that the user can have contextually relevant responses back, right? So RAG basically connects your AI application and systems with external data sources so that accurate and contextually relevant responses are given back to the user or generated. As you can see, right, there are three steps here. One is document processing. So your custom documents gets processed. What does that mean? Your documents gets chunked, and all these chunks are they get converted into vector embedding using embedding model. Can be OpenAI embedding model or Cohere embedding model, and all these vector embeddings are stored in a vector store like single store. And then comes the query processing. That's where the user asks a query. And then even user query gets converted into a vector embedding. That's why we call it a query embedding. And then using a vector similarity search, it goes through the vector store to find the relevant chunks. So now you have augmented query and then the relevant chunk. At the end, it goes through the LLM model to finally give you the contextually relevant response. So this is how basically RAG works. And yeah, I mean, again, same with a little bit of simple code, like how actually RAG works. It's all starts with the query processing. The user's query gets converted into vector embedding to make it searchable in a numerical format. And then the retrieval thing comes in. The system searches for the top three documents that are similar to the query embedding, and then context augmentation happens. That's where the retrieval of documents happens, and then it goes through the LLM model to finally generate the response back to the user. So these are some of the key components of a RAG. You need to have a proper vector database in place that is very robust, something like single store database that supports real-time data, real-time analytics, um, which has a good integration with LangChain and LlamaIndex, by the way. And you need to have an embedding model. You need to select proper embedding model, whether it is OpenAI embedding model, Cohere, or anything from Hugging Face, and selecting a large language model to generate your responses like chat, like OpenAI has GPT-4o, which is kind of really good. You can also use something from Claude, the recent ones, and then document processor, chunking documents, and you need to have a proper retriever and prompt templates in place to basically design your AI application properly. And even you can use prompt templates from LangChain, right? So those are some of the simple components of RAG. And here's a simple example use case of a RAG. Like without RAG, if you build a system or a chatbot just with pre-trained LLMs, like we saw before, if you ask a query like what treatment options for this patient with stage 2 NSCLC. So if you ask a query with your system that has just pre-trained LLMs, the response back is not good. Like it's not correct. It's like very old response, very outdated type of response. As you can see, based on my training, standard options include surgery, chemotherapy, or radiation therapy. That's it. So, but if you with RAG, if you give your pre-trained LLM some additional context through your vector database. If you ask the same query, what treatment options for this patient with stage 2 NSCLC, as you can see now, you have the augmented custom data there. So LLM can easily go and fetch the relevant response, relevant matching data chunks, and then easily respond back saying, hey, based on 2025 NCCN guidelines and recent trial, keynote, blah, 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 consider immunotherapy with blah blah blah. So it is more accurate and very contextually relevant response. So this type of response is what we need, and that's where a RAG helps you with. So again, it's the same thing like with RAG, without RAG. User asks what treatment exists for antibiotic resistance, and RAG fetches relevant documents. Uh, it goes through the recent medical journals or research papers, and LLM processes with context, and that's how you get a comprehensive answer. But with just pre-trained LLMs, since it has no access to the research papers or any research reports, and pre-trained LLMs have limited training data. They have their own cutoff date, so you get a kind of outdated or incomplete answer. So that's where RAG shines. And yeah, again, traditional LLMs, the difference between traditional LLMs and RAG systems, right? Traditional LLM will have a fixed knowledge cutoff date and no access to private data or custom data. So you can't build a custom application, AI application or LLM application, and knowledge encoded in parameters, frequent hallucinations, and limited context window with traditional LLM, and no citations or sources, static knowledge base. Whereas in RAG systems, there is up-to-date information, and you can actually have access to the proprietary or custom data, knowledge stored externally using a vector database, and reduced hallucinations, expanded effective context, and verifiable information sources and dynamic knowledge updates. You can keep updating your database so that RAG system can easily fetch the relevant responses or the chunks. So again, LangChain in RAG. So LangChain basically provides the necessary tools at through models for RAG applications. So as you can see, right, this is a simple RAG workflow. If you consider, um, LangChain has document loaders, text splitters, and embeddings. It has good integration with vector stores. So and uh, it also can help you with similarity search, and it has LangChain has open source, closed source LLMs that you can use. So as you can see, there are two pipelines, the document processing pipeline and the query pipeline that I explained in the RAG. So LangChain basically provides a different tool set through models to help you build proper RAG or AI applications. LlamaIndex RAG pipeline. Similarly, LlamaIndex basically simplifies building RAG pipelines by providing uh, tools at different stages like data ingestion. It has, you can ingest PDFs, text, web pages, and it helps you with indexing, query and retrieval, and then generation. So that's it about both LangChain and LlamaIndex pipelines. And these are some of the RAG performance optimization techniques that we need to know, like which chunking strategy to use. Should I use a normal chunking strategy or semantic chunking strategy, and the type of embedding models to be used, the vector database to be used. So select appropriate vector DB based on the scale, not just because GenAI is all hyped up and now even like every week vector databases are popping up. So it's better you have a database that is scalable, and retrieval methods to know. You need to have prompt engineering in place and caching techniques in place. So these are some of the RAG performance optimization techniques. So AI or LLM app development without framework. So at each stage, these are different layers when you're building AI or LLM applications. So at each stage, as you can see, there are a lot of efforts or the challenges that they occur, like API authentication, rate limiting, error handling, like memory and context, knowledge base integration, and output processing, and all those things. So that's where you have these frameworks like LangChain and LlamaIndex with their key features that help you build proper AI or LLM applications, right? So yeah, this is a simple, typical enterprise data architecture, right? So let me explain why this is so complex, right? As you can see, the image itself is kind of complex. So you are a company, and when you start, right, so you feel like your customers are running a lot of analytical workloads. So you feel like having an OLAP database in place. And after some time, you grow as a company, and you also feel like, hey, some of my customers also demanding for a transactional database because they are running a lot of transactional workloads. Then you get another transactional OLTP database. And then now the all the hype is all about Gen AI applications, and you feel like having a vector database in place. So for any data architect in your company or any AI engineer to maintain data, to this architecture is kind of very complex, right? Using different, maintaining different databases at different stages to do different things. So why not replace everything with all-in-one data platform like single store? Because at that time I'm like, if you use single store, there is no need to use specialized vector database for similarity search, hybrid search, re-ranking like elastic search. You don't have to use, and that's where single store db comes as an all-in-one data platform to help you with ingesting and indexing documents, re-ranking, filtering, similarity matching, and single store supports all types of data, and it has a good integration with LangChain and LlamaIndex so that you can build robust AI RAG applications. So this is where we usually used to say the only database you will ever need. Now it is changed recently. The website, we got a new look recently. So these are some of the global leaders that they choose single store for their real-time analytics to build AI applications, RAG applications. Some of them are DBS, Dell, ENY, Hulu, Comcast, Siemens, Samsung, and many more. So here's simple. This is what we're gonna do: build a RAG application or a system with single store using LangChain. So I have a publicly available PDF file. I'm going to chunk it and create vector embeddings. And all these vector embeddings I'm going to store in a vector store, vector DB like single store. And then I'll ask a query, and then it goes through the vector store like single store to find the relevant chunk. And then it goes at the end, it goes through an LLM to finally give me the answer back, contextually a relevant answer back. So let's see that in action. For that, you need to have a single store account. Single store has free share tier. You can go ahead, sign up, you get free credits and try using it for free. You can use my bit.ly link or directly go to single store, or I can also share the link. So you're
Pavan, I've already shared your UTM link.
share.
Yeah,
Oh,
I've
done,
already
done, done,
UTM done shared.
done. So yeah, once you have that, I'm using OpenAI API key, but you can use other free keys because OpenAI is kind of you need to pay for OpenAI. So first thing is to create a workspace and a database. I'm going to show how, and create a new notebook, and then make sure select workspace and database on your notebook, and then we can go ahead from there. So let's go to single store. Hope you're able to see my screen, and I'm already registered. So I just log in. So once you log in, you usually land here. This is the whole dashboard that you'll see. So create a workspace, just click create workspace, and then attach to your workspace, create a database. So I have already created my database like LangChain, and the database is LangChain, and then the workspace is PowerAPI workspace. It's all ready. So you can go to data studio. So one good interesting thing about single story is we have integrated notebook environment here itself. So you can create a new notebook inside itself and to build your AI or RAG application. So just create a new notebook, name it, and just create it, make it shared or personal. So I have my notebook already. It's all ready. So I just go here, let it load. So yeah, once it loads, let me explain. Yeah, so RAG using LangChain and single store. So the first things first, here in the dropdown, select your workspace and select your database that you just created. And first thing is to install libraries and dependencies. I'm using LangChain. I'm also installing single store DB. I have a PDF file that I'm going to load. So import the libraries. That's what I'm doing here. And I'm loading the custom document. So this is the document I'm loading. This is about, let me see what this PDF file is all about. So this is something about global monitoring report on non-bank financial intermediation. So 2024, some report. So I'm loading that. Next is to split the document into chunks. So we did that here using recursive character text splitter, and As you can see, you have 76 documents in your data. There are 86 characters in your document. You have 121 pages. So, and then using OpenAI API to generate embeddings. So that's what I'm doing. Here, I'm passing OpenAI API key to generate vector embeddings after creating chunks of our data. And then now it's time to store our vector embeddings into our database, right? To store vector embeddings in our database, we need to have a table. So we are creating a table, FSB table, and then using the strategy there, the dot product, and we are storing all the embeddings. And then let us check the text chunks and associated embeddings stored in our database. So this is how it gets stored. I can show you that. So once everything is stored, now let's ask a simple query using just similarity search to retrieve the top k closest content, right? So I'm asking a query, what was the growth rate of NBFI sector in 2023? So this answer is actually present in this report actually, right? So using just the similarity search methodology, it just goes through the similarity search method and finds this type of huge chunk. But we need a proper answer, right? So we don't need a big answer like this. So here is the augmented response to the user query, right? The model used here is GPT-4. You can change the model. As you can see for this query, what was the growth rate of the NBFI sector in 2023? You can see the proper contextually relevant response back. The growth rate of the NBFI sector in 2023 was 8.5%. So this rate was more than blah, blah, blah. So better than the previous one, like this big chunk. So if you test the same thing when the knowledge base is not provided, as you can see, right, for the same query, if the knowledge base is not provided, what was the growth rate of NBFI sector in 2023? As you can see the response back, right? The growth rate of NBFI sector in 2023 cannot be accurately predicted as it is dependent on various factors, blah, blah, blah. So that's how you can basically feed your custom data and create your custom AI or RAG applications. So that's about how you can basically build RAG systems using LangChain and single store. And then next is the same, like I'm building RAG systems with RAG application with LlamaIndex and single store. As you can see, I have again, I think a PDF or a CSV file. I'm going to show you in the tutorial. One second. So what I'm doing is I'm loading the document and converting them into chunks and creating embeddings and storing them again in a single store DB vector database and fetching using when a user query comes in, it goes through the vector database using similarity search to find the relevant answer back. Here I'm using LlamaIndex. So again, uh, hope you have the account, and I'm just going to go directly to the code here to explain you what I'm doing. So RAG with LlamaIndex, same thing, install the required libraries. I'm installing LlamaIndex, single store DB, and other required things, OpenAI, and then import libraries. That's what I'm doing here, and then setting my API keys. OpenAI API key and single store DB URL, and then download and save PDF. Here I'm downloading a PDF. So this is the PDF I'm using. This PDF is about some world economic situation and prospects 2023. So I'm feeding that, and as you can see, PDF downloaded successfully to this, and then I'm initializing the single store vector store using the table name and content field, metadata field, and all those things. So mention the embedding model. I'm using model GPT-4, and then load and process the document. As you can see, number of documents loaded 178. Blah blah blah, and create and process the index. That's what I'm doing, and function to query the index. And then the example usage, I can chat with my PDF with the following queries. Like if I ask what are the main economic challenges discussed in the report, these are some of the queries that I ask. And here you can see the query and the response back, proper response back, right? What are the main economic challenges discussed in the report? Response: the main economic challenges discussed in the report include tight labor markets in development economies, the world being off track, blah, blah, blah. So for every query, there is a proper contextually relevant response back here. So this is how you can basically use Llama Index to build RAG applications along with single store as a vector database. So yeah, uh, many people ask like, should we use LangChain versus Llama Index? But again, it all starts with defining your RAG system requirements. What is your goal? The primary need, as you can see, this is type of overview, not a fixed thing. If you focus more on the primary need is more on complex orchestration, it has you are building advanced workflows and chaining agents, memory management, then you can go for LangChain. And when your primary need is more on the data side, like data indexing and retrieval, efficient data ingestion and retrieval, you can use Llama Index. But if you have mixed requirements, you can use combine both LangChain and Llama Index sometimes. And this is how you can basically combine LangChain and Llama Index. But I have not seen many people combining both because it's going to be a very overhead for your company and also to your engineers maintaining both, right? But usually I won't suggest this, but this is just a simple overview of where you can use when it comes to your data, like indexing and all those things. You can use the first half in your AI application or building RAG applications. The Llama Index can be used, and in the next half of the AI application, you can basically use the LangChain for building prompt templates and querying data and all those things, connecting with LLMs. Yeah, so that's about today's presentation, and thanks. Let me see if you have any queries. A lot of
Okay.
queries. I'm not an AI.
No,
Yeah,
no, this was
yeah.
awesome. I'm telling you, we have so many questions for you, and seriously,
Oh,
this was very interesting. So, like, can you check the Q&A button yourself, or do you need
yeah,
my
yeah,
help?
yeah. Yeah, yeah, I'm doing that. I'm doing
Okay,
that.
awesome. Okay.
Can MCP, guys, I'm not an AI expert. I learn things and I'm very new to presenting things. So uh, please excuse me if I'm not able to answer, take your questions, certain questions. You can always ping me on LinkedIn. I'm very active on LinkedIn. So can MCP of data source a replacement for LangChain? No, MCP is completely different than LangChain, right? That's model context protocol. And LangChain is basically a framework that you can use. But yeah, that's interesting but thing. But it's not a replacement. MCP is not a replacement for LangChain, is what I can answer. And single store also has a MCP. By the way, you can go and try that. I want to access these sessions, recordings, and resources. I think you will get these resources to your email if you have already registered. Uh, so yeah, difference between Llama Index and Llama Cloud. So I think I should, right? So here it is. And I talked about Llama Index. Where is it? Let me go to that. So here it is, right? Llama Cloud is all about, kind of a centralized index to store all your indexes. And with that index thing, you can connect that data with your Llama index and basically build all types of chatbots and search applications and agentic workflows. What about using tools like Space for NLP tasks? What's the difference between LangChain? I am not very sure about the this tool that you're talking about, but I heard about it, but I'm really not sure. I'm sorry. Can I stick to LangChain? Well, LangChain is if you want to build LLM powered applications where LangChain basically gives you all the modules, all the tools that are required. So better to experiment with LangChain. So Yeah, if not LangChain, I would suggest LlamaIndex, the next one, right? So yeah, this section is recorded and you will get the recorded thing and implement a solution which involves multiple passes. Example given, skipping the analysis to see this is how complex should be the system architecture and vector storage requirements to consider single. See, the difference between single store and Pinecone. Pinecone just does it. It is just a vector database. So with all the GenAI hype, there are a lot of vector databases popping up each and every day now. But single store started supporting vector storage long back in 2017 itself. So now you can see the scale, the amount of data that single store can, the latency that single store has. I mean, the fast ingestion, and single store is not just used as a vector database. The big banks and all use it for real-time analytics. So you can, on top of your AI applications, you can, if you have the like you can build real-time analytics. You can see the dashboard and all those things. So yeah, what about the prompt engineering method? They will be also using. No, RAG is different. So prompt engineering is just playing with your prompts and seeing the outputs, right? The prompt is nothing but the way you ask a query to like question to the LLM. That is completely different. You can't minimize the hallucination there. But with RAG, like the name suggests, right? Retrieval augmented generation. You're giving some extra context to your system where your system can easily fetch the relevant chunks from that augmented thing. So that's where the vector database comes into the picture because all the context is stored, the data, your custom data is stored in a vector database. And prompt engineering is just the art and science of playing with your prompts. That's it. So do you envision the medical knowledge component evolving toward multimodal knowledge, example, combining clinical text? Yep, yes. Stores lab and for vector stores like single store guy. Yeah, you can use single store for that. That's a very big question. Like, let me see this video. Only partially see slides. Is it? But okay. Change your embedding model. If you change your embedding model, does single store require you to re-index all the document? No, like if you change your embedding model, you can use different embedding models and no need to index all the documents. If so, how long will that take? It depends on your the how long your PDF or the document that you're using. But you can always change the embedding model. You can use Cohere embedding model, anything from Hugging Face or OpenAI model. Does the system need to be offline during the indexing? No, nothing like that. Can I think of single store as another vector DB? No, single store is very old and very big company compared to all the vector DBs. Vector DBs, like I said, right? Vector DBs are just all the hype because of the Gen AI hype, and they just do vector search or hybrid search well. And apart from that, they don't do much. But single store, like I said, right? Big companies use single store for real time analytics and much more. And single store supports all types of data and it helps you with the workloads like if you have analytical workloads, transactional workloads. But vector DBs can't handle all types of data and all these OLAP, OLTP workloads. Right? This works with PDF having mathematical equations and figures. Yes, it works with PDF having mathematical equations and figures. Just use it and see. Yeah, I think this the slide will be shared, the PPT, everything. May we see the architecture graph, the second page. I don't know which one you're talking about, but this will be shared by the end. How about using noise graph or graph rack? Is it useful tools? Yeah, you can use that also, but yeah, I mean, Knowledge graphs you can also use. That's the new concept like graph rag. But single store also supports building knowledge graphs, so you can use single store uh, instead of other uh, databases. I mean, like I said, what is your suggestion to implement knowledge graph in your AI applications? Applications. Single store itself supports knowledge graphs. So there is already a video on our YouTube channel. You can go and check that out about how you can use single store to build knowledge graphs and RAG applications. The tech of AI agents and agentic AI in 2026 in production. What is your view on the uptake of AI agents and agentic AI? So all the hype now, agentic applications, agentic AI, agentic RAG. Today only I made a video about agentic RAG, how to build agentic RAG systems with using LangChain and single store. So, I mean, it's all in the overview. I mean, like many people, I don't think many people are trying things in production because, yeah, I mean, if some people are using LangChain, many people complain. I saw in the Reddit saying LangChain keeps breaking a lot of things and all. But yeah, I mean, but everybody's is experimenting with these things yet. So still they are experimenting and yeah, but by 2026, I think most we'll see everything in reality, right? Just like how ChatGPT came and everything changed suddenly. Agent to respond to the question is to give an response. Did you have to call an AI agent? No. I just showed you the RAG thing. So there was no AI agent involved here. It was just a RAG setup. That's it. Using my own custom data, which I stored in a vector database like SingleStore, I just used an LLM to call that. That's it. There is no AI agent here. How about Crew AI? Is it a robust LangChain? Crew AI is basically to build agentic workflows, agentic applications, like multi-agent workflows, multi-agentic applications. Is it a robust as LangChain and LlamaIndex? It is. So that is used for completely different purpose, and this is used for uh, different purpose. But along with Crew AI, you can use both LangChain and LlamaIndex. Yeah. Do you have a short video on single store introduction? Yeah, yeah, we have. You can go to our single store YouTube channel and we have a lot of videos how to use single store and how to ingest, how to index data and all those things. Vector search, hybrid search, when single store data is used. How to improve the index retrieval when there are different techniques like I showed, but if you use single store like vector database, how to improve the index retrieval. Index retrieval, I didn't get this one. Yeah, yeah, I can do AI agents tutorial. I am planning to do that. I just told Yukti that I'm gonna do something on AI agents. Why say vector database? You need to vector because the text gets chunked and all these chunks get converted into embeddings. That's what we call vector embeddings. So that's the name, the numerical format. That's why. So all these vector embeddings are stored in a database. So since vector embeddings are stored in a database, so we call it a vector database. So as simple as that. Job scheduler option in single store. I'm not very much sure about this, but yeah, yeah. I mean, Yuki almost done. I think.
Awesome. Okay, so if we are done, folks, if you have any questions that you feel like were not like answered, you can reach out to us at team@singlestore.com because we are almost at time now. So we'll have to wrap up. So I actually have posted some resources for everyone to check out in the chat. So we have an amazing product launch that's coming up on 17th of June. It's called the Upsert event. It's called feeling the flow. So if you're interested in that, I think Pawan can talk about it in much more detail as compared to me. But it's an interesting event and it has a lot of new cool features. It's basically, correct me if I'm wrong, I think it's one of the newer versions of Single Store that's being
Yeah,
launched. And the product team has actually worked really hard on that. So if you are interested, feel free to check that out. And we also have a partner webinar that's coming up with a with data loops. So if you're interested, you can obviously sign up for our auto RSVP tool, and you'll automatically be added. And if you're not able to join like live, so you'll obviously get the resources and everything, so you can later on tune in and uh, you know s- check out the webinar at your own convenience, because I understand it's very difficult to attend the entire session. So this session is currently recorded and everything will be shared to you. Pavan, you mentioned that you have a GitHub notebook. I Please share that with me, and I will
Sure,
the follow-up
I'll do
email,
that.
and make sure to
Yeah,
include that.
sure.
So once a reminder,
Also,
yeah.
also, folks, I mean, like you can connect with me on LinkedIn. I keep sharing a lot of AI related stuff, videos and Gen AI related stuff. Yeah, articles and all those things.
Yeah, if you have any message, feedback, anything that you want to discuss about, you can reach out to Pavan, or you can also reach out to me if you have any ideas for any future webinars, any suggestions that, hey, we would like you guys to see, like we would like to see a webinar on this particular topic. So we love to hear that from the community. And we also have a Discord channel. So if anyone's interested in continuing any discussion, you can join our Discord channel. I will include that link in the follow-up email. So yeah, I hope you like today's webinar. Your time is really precious to us. So we hope to see you all next time, and have a great rest of the day. And thanks, Pavan, for conducting this amazing session. It was really insightful.
Thanks, Yukti. Thanks, guys. Thanks for joining.
Thank you,
Bye bye.
everyone. Bye.